Undersensing is where the pacemaker fails to register depolarization of a chamber. Let us have a look at how this may appear on an ECG. In this example, the pacemaker is sensing the atrial depolarization, it starts its AV delay, and then the intrinsic natural depolarization of the ventricles occurs. The pacemaker sees this and registers it as a V-sensed event. The same occurs here. However, on the next heartbeat, we can see that atria depolarizes. This is sensed by the pacemaker. It then starts its AV delay, but this time it hasn't registered that a ventricular depolarization has occurred. So, what does it do? It tries to trigger a depolarization itself. This is what a pacemaker is programmed to do. You can see here it delivers its output pulse, which is signified by this pacemaker spike, but actually it fails to depolarize the tissue. The reason is that the tissue has only just depolarized and is now repolarizing and is refractory. What this means is, no matter how much electrical energy you deliver to tissue when it is only just depolarized, it will not be able to depolarize again. This is like a flushing toilet. Once you've flushed the toilet, you have to wait again before the toilet is ready to flush once more. And it's the same with cardiac tissue. So here, although it's tried, the tissue is not ready, and so it doesn't trigger a ventricular depolarization. Normal service is resumed on these next two heartbeats, so we can say that this is intermittent undersensing. In the example below, we can see that atria depolarizes, the AV delay is started in the pacemaker, and again, the ventricular depolarization isn't sensed. So just like the previous example, the pacemaker sends an output pulse. This fails to capture the now refractory ventricular tissue. This happens on all of the heartbeats on this electrogram, and so we would say that this is permanent undersensing, absolute, chronic undersensing. Just to highlight these once more, I've marked all the events where the pacemaker fails to sense on the electrograms. So, what is happening? Well, for whatever reason, the pacemaker is not sensing the ventricular activity. This is quite often because the ventricular signal has become too small in amplitude. And here we can see that the pacemaker sensitivity is set at 4 millivolts and therefore it is ignoring these ventricular events which are less than 4 millivolts in amplitude. If this was the case, we could resolve this by making the pacemaker more sensitive. Once more, we are detecting all these ventricular events and normal service is resumed. However, it can be indicative of bigger problems that aren't so easy to solve. This includes lead displacement, lead insulation break, or a lead fracture. Let's break them down. Lead displacement is where the lead has come away from the myocardium or the position that it is meant to be in. This occurs most commonly in the first 4 to 6 weeks after implant, where the pacing lead has not had a chance to fully fixate itself to the myocardium. So, the lead is displaced and the electrode is no longer in direct contact with the myocardium. This makes it much more difficult for the pacemaker to sense the depolarization of that tissue. The signal becomes much quieter and much smaller, so the pacemaker will not recognize this signal as a ventricular depolarization. It could also be indicative of a problem with the lead insulation. Now, pacemaker leads have a metal wire that is insulated by a non-conductive material. This ensures that the electrical current makes it all the way down the lead before leaving at the exposed electrode, the metallic electrode. Unfortunately, the insulation of a lead can sometimes break. If it does break, the point at which the insulation has broken, the wire essentially becomes a new electrode. So because of the insulation break, we have a new sensing circuit, and it is not sensing the tissue that we're interested in. In this example, it may pick up a small amount of atrial activity. Again, this will not be detected by the pacemaker. Finally, it could be indicative of a lead fracture. Essentially, a fracture in the wire of the lead has meant that there is no connection between the two new parts within the lead. So, any electrical activity that is given off when the tissue depolarizes may enter the lead, but can never make it back to the pacemaker. So, your takeaway message? Undersensing can often be resolved by making the pacemaker more sensitive. However, a faulty lead will need to be replaced or repositioned.